This presentation was prepared in Argentina jointly by the Argentine Wind Energy Association and the Argentine Air Force. Our task was the development of a wind turbine for extreme weather conditions. Two general goals. The challenge was to develop a wind turbine that could work in extreme weather conditions, such as the Antárticas. In this case, it is important to mention that the geographical environment is special, as it is unstable and particular. Antarctica's general weather conditions. It is the cleanest continent in the world, but the most isolated and inhospitable as well. Wind and temperature conditions are extreme, especially in the area in which Argentina has focused its activities. Under these conditions, the energy is vital for human survival. Normally, this energy comes from fossil fuel. 6 permanent bases and 6 temporary bases carry out the activities previously mentioned. Our research is carried out in the Marambio base, located in the Antarctic Peninsula, in the Marambio Eximor Island, on the Weddell Sea, and it is administered by the Argentine Air Force. This base provides continuous support to the national Antarctica and the surrounding global community by air. As it has been said, due to the extreme weather conditions, it is vital to have a source of clean energy. The thermal regime presents a simple annual wave in which the lowest average temperature is -11 degrees Celsius and the highest -20 degrees Celsius, with a wind chill of -40 degrees Celsius. Throughout the year, winds are recorded on an average higher than 12 meters per second, with gusts higher than 60 meters per second. It is important to consider these extreme weather conditions to design the wind turbine. The video shows how extreme the weather conditions can be in the Antarctic region. The Marambio base is located on a plateau 200 meters above sea level. Due to the plateau's steep 45 degrees angles, it is impossible to access it from the coast, and this limits the size of the wind turbine. Permafrost is a permanent frozen ground, which is the main feature of the island's ground. Its structure's permanent temperature is of -degrees Celsius, but its surface layer is actively variable. Changes in thickness and consistency are directly related to the environmental conditions and time of the year, which limits the wind turbine's foundations. Marambio Plateau's soil roughness is a Class 1 roughness, according to the European Wind Atlas. Variable roughness is an effect produced by accumulated snow solidified in the same place for a long period of time. These consequences produce a more turbulent wind surface and the inability to quantify new terrain roughness. Snowtail is what we call dragged snow deposited downwind of structures and buildings, which are often covered completely by snow. All food, fuel and other supplies arrive by air, as there is no port in the island, and this is done with the Argentine Air Force Hercules C-130 aircraft. During the Antarctic summer, an icebreaker is anchored at 6 kilometers from the base, so that helicopters can supply the scientific base. This video shows how supplies are transported by the helicopters to the base. Development of the wind turbine for extreme weather conditions. Main concept. It is a downwind wind turbine with the ability to hold back its blades. This allows the variation of the frontal area swept by the blades, depending on the intensity of the wind. The more the wind blows, the smaller the angle between the blades is. Specifications: S-class wind turbine. Rated power 5 kilowatts. Rated speed 11 meters per second. Rotor diameter 4.1 meters. Designed to withstand gusts of 60 meters per second. Low maintenance. Foundations on high to avoid the effect of snow tail. Its design is based on DNV rules for offshore wind turbines. The virtual prototype, from its individual components to its mechanical integrity, was designed using a standard-designed software. The video shows how the prototype wind turbine starts and its response to different wind variations. In order to calculate the blades, a self-developed software for aerodynamics has been used, based on the theory of the blade elements. For the structural calculation, a software of standard finite elements was used. For the blades, materials with fiberglass in an epoxy resin matrix have been used, as they present an adequate thermostability and a good response to mechanical stress. Authentic stainless steel was used for the remaining parts. This material proved to have good mechanical properties even at cryogenic temperatures. Corrosion and brittle fracture are expected to be avoided when operating at extremely low temperatures. In order to prevent the snow tail effect, the foundations are raised and supported on the permafrost. An alternator with a permanent magnet rotor and a stator winding copper were designed for power generation. Long periods without maintenance are expected, as well as no bearings or brushes, and a high performance and low RPM due to its large number of poles. The energy produced is directly coupled to the grid of the Antarctic base. The turbine will be installed to an inverter of this direct coupling. Usually, the electric grid is powered by a diesel generator. The current status of this project is in the state of testing, for which it is installed in the city of Rio Gallegos, Argentine Patagonia, because of its similarity with the Antarctic's conditions at certain times of the year. The video shows a wind turbine testing in the Argentine Patagonia. Thank you for your time. It has been a pleasure to share this presentation with you. For any further information, please contact us at the email address shown below.